Okay folks, welcome back. So this is another video in this series where I'm using RStudio to conduct data analysis and data science tasks. In the previous few videos, we looked at data visualizations, so visualizing the distribution of variables and things such as this. I'm going to leave that alone for now. There are many more data visualizations, ways of plotting data, creating figures, that we could go into, and some of them getting a lot more complex than the basic ones that we covered. But I'm not going to do any more visualizations for now. What I'm going to do instead is kind of move on, and we will, in the next couple of videos, we'll start looking at descriptive statistics. So these are numerical summaries of variables. Essentially, they give us information about the measures of center and measures of spread for particular variables, so we can understand their distribution. And they're often, when you do some sort of analysis and write up the results, they're often the kind of the first thing that you report to make it, along with presenting some sort of visualization of the data, to make people aware of kind of distribution of it and the assumptions you're kind of making with the tests that you're doing. But what I'm going to do in this particular video is I'm going to just demonstrate how to use, so this is video number 20. I'm going to demonstrate how to use a really useful function called the summary function, which will give us like a 6-number summary of some quite useful descriptive statistics, such as the mean, the median, the interquartile range, and things such as that. And what I'm going to do is I'm going to use the tidyverse. I'm going to load the tidyverse up because we'll possibly use that in some way. But I'm also going to import a data set. So it's the MT Cars data set. It's this publicly available data about, I think it's from Motoring Times magazine from like the 70s, about 32 makes of car. This is a built-in data set in RStudio. I have a CSV version of it saved on my device, and I'm going to just use that because it's been mostly on this series of videos I've focused on built-in data sets, but it's sometimes good to just kind of review and repeat demonstrations of how you import your own data. So I'm going to import this MT Cars data set from a CSV that is saved in this particular folder. You can see the folder I'm in, data analysis. So I'm going to start us off. I'm going to import the library, the tidyverse, using the library command. You can see that's worked. It shows us the conflicts and things like that, but that's loaded up nicely. And then I'm going to import the MT Cars dataset by passing the name and the extension mtcars.csv within quotes in parentheses to the read.csv method. And I'm assigning this a name, so I'm going to call this. I'm creating a new object, calling it df for data frame. You can see there, if you look in my environment, if it's imported this, we've now got a data frame object. If I say data.frame, 32 observations of 12 variables. Okay, so 12 makes a car, 32 makes a car, and 12 variables, different information about them, such as their mileage, top speed, I guess, transmission, things like that. If I do glimpse on this data set, what you can see in the, if I make this slightly bigger, that might help. In the output window below in the console, you can see that has it gives us the glimpse is quite useful because it gives us each of our variables. We've got our 12 variables. It tells us the type of variable, the data type that it is, and then it presents some of the data. The interesting thing about this is this has imported the data. It's recognized that model of car, which is a string, as a character variable, and then it's got double precision or decimal representations as DBL, and ints for integers. But a couple of these, although it's recognized them as integers, which they are, such as AM, so that's transmission, I believe, automatic or manual, like a 1 or a 0. This is actually a categorical variable. And the same with gear as well as a categorical variable. Does it have 4 gears, 3 gears, 5 gears, etc., that type of thing. So some of these data types have not imported correctly, and we might want to change that. I'll demonstrate that a little bit at the end of this video. But first of all, what I'm going to do is just demonstrate the summary function. And we can use this to obtain this quick 6-number summary of the distribution of scores for each variable. So if I just use summary as a command and I pass the df, so this is going to give us a summary for every single variable in our data frame if I do that. And you can see it presents each data, it presents them as little tibbles or data frames essentially. You can see model, there it tells us there's 32 models and it tells us its character variable. But for the others, such as MPG, it gives us the minimum MPG, the median, the mean, the maximum MPG, and the quartiles, the interquartile range essentially. So we get in this kind of interesting 6-number summary here, and the same for the other variables. So the ones that are actually double precision or integer numeric variables are the ones that this information is most useful for us. So we want this type of information for MPG, but as I said above, we didn't quite get these other two variables. Like these are categories AM and gear, and if we look at them, it kind of returns this type of statistical summary for AM and gear, but they kind of this is pretty much meaningless for these, certainly for this variable AM and for gear, because they fall into one of two categories essentially. I'll demonstrate how to tidy that up later, but first let's play around with summary. It's already given us some quite useful information for the whole data set. It's taken every variable. If you've got a large data set, you'll have a lot of output on your screen here, but we've only got 12 variables in this case, so we can select individual variables that we want this summary for. So what I've done here is I'm calling the summary function, I'm telling it I want DF, and then I'm using the $ and WT. So that's the weight variable that we've got here. So it's going to return this same little data frame object that we've got here. But all I'm doing here I'm using the summary command, and I'm saying from the data frame extract weight using that selector to index that $. And you can see what it's done. It's returned exactly the same data as we had above, but in like a horizontal format, so it's more of a vector. So let me demonstrate a couple of things in relation to this. You can get the output in different ways. It doesn't matter really because it's the same data, but if you look, what I'm going to do here is I'm going to use the pipe operator. So I'm going to take the data frame and then pipe that as input into the select function, and I'm going to ask it to select displacement. Okay, so that's one of our variables, displacement. If we go up here, it's a numeric variable, I believe. There it is. Okay, and then I'm piping that into the summary command. So doing a similar thing to above, we're going to use select to return a small data frame that's kind of vertical, like these ones that we're looking at the moment in the output below. So if I run this command from lines 24 to 26, you can see it's just selected the displacement variable and it's returned it as this kind of little mini data frame type of object. If we use, there's a different, so that was the select method or function, whatever you want to call it. If we use it, there's another one we can use there. If we use the one here called pull, exactly the same command, only I'm replacing select with pull. This is going to return that vector representation, so like that horizontal representation that we saw previously. So if I do that, same data for displacement, but it has put it horizontally along a line. So it doesn't really matter which you use, it's the same, it gives you the same data, it's kind of down to personal preference. Okay, so I said before, if we scroll back up a bit, we've got our data set here is imported, but there are a couple of issues with it that we probably want to deal with if we were doing some real meaningful statistics with this. We've got categorical variables that are dummy coded, and they've been imported, recognized by R as integers when they're actually categorical factors or factorial data types. And we can do the same with gear. So what I'm going to do here is I'm going to change these categorical variables to factors so that they return some more meaningful data. And notice what I'm doing, I'm creating a new object called df2, and I'm using this assignment operator, that less than, minus, that little backwards arrow. So what I'm going to do is I'm going to take the data frame object and I'm going to pipe that into the mutate function, and then in the mutate function I'm passing two things. Firstly, I'm saying take the AM variable and then as dot factor and I'm passing that same variable name. So I'm not changing, I could change the name of it and it give us a new, it'd append as a new variable here, but I'm just leaving it the same. So what I'm doing is I'm saying take the AM variable and convert it to a factor. And then a comma, and then doing the same with gear. I'm saying gear is now going to be a factor, so convert gear as it's saved here to a factor. And then I'm piping that into the glimpse function so we can see if it's worked. An important thing to note here is if I hadn't included the assignment, assigning it as a new object, and I just ran this command essentially, this would do, it would work and it appear as a factor, but then moving forward, it would kind of only save an image of that. So when I then went to do further analysis on df, these would return to being integers. So if I ran this command, it would appear as a factor, but if we then ran glimpse again on df, the original data frame would still be intact, and AM and gear would be shown as integers, which we don't want. So what we're going to do is we'll just overwrite them, and I'm going to run this command there. Now, and you can see now we've got our variables, and you can see that AM, that's the automatic manual transmission, that's now a factor, and so is gear. They're both now kind of categorical variables. And we've got a new df2 object here. So if we run summary now on df2, it returns like the kind of summary for all our different variables. We can see displacement, it's still got its numerical, its mean, its median, that's the type of thing. MPG also, that's kind of the type of data we want. But now if we look at those two variables we converted to categorical variables, you can see AM and gear are both here. And now what we're seeing is the different categories. So 0, I think, may be automatic, 1 might be manual, is how it's been coded. We can see we've now just got frequency counts for those, how many fall into each category. So 19, say, automatic, and 13 manual. And then for gear, a similar sort of thing. We've got 3 gear, 4 gear, 5 gear, 15 cars had 3 gear, 12 cars had 4 gear, 5 cars had 5 speed, 5 gear gearbox. Okay, so that's essentially the summary command. Good way to obtain some really basic descriptive statistics just on the distribution of your data. Remember, we've not got anything here about the standard deviation or anything like that. In the next video, we'll look at another really useful function in a different package that will help us with that. Okay, that's all for now. Thank you for watching and listening.